Hello, everyone. Welcome back to another video. This is Eddie again from the Sports Analyst Club. Today, I'm going to go over how to scrape off of website. That's how I, so when I started out learning Python, that's the first main project I ever did was just scraping off of Pro Football Reference. I'll show you what we're going to scrape off. We're going to go to the summary. Yep. So it's going to be the summary of 2024, and we're just going to scrape off of the AFC and NFC standings tables. And luckily for you all, I'm going to do my best to muster through this, and there probably will be mistakes on this. I'll try to do my best to catch on to them as quickly as possible. Uh, but luckily for you all, this will be a good example to go off of just because when I started out, I didn't really have an example to go off of for scraping a table because I didn't really know where to look. Luckily, you've got a video that shows you exactly how to do it. So if we want to get things from this table, let's first think about web scraping this way. When you open up a website, you're essentially you're making for lack of a better term, a request to that website, like permission to open it up. You've got things in the background that are talking to each other, like your computer, and your DNS is talking to that websites and it's giving you access to open it up. Um, if we want to scrape off of that website, though, we're not going to be able, I mean, it wouldn't be worth copying and pasting all this over. I mean, you can if you want, or you can export it as a CSV, but that kind of defeats the purpose of this example of scraping. So what we're going to do is we're going to use a library called requests. And it's a library that sends out HTTP requests to that website. So it's kind of like mimicking you opening up a website, like clicking on a link and opening it. And you can do various things with it. So you're going to need to pip install it. If you want to pip install it on a cell, you can use like a percent sign or an exclamation point, and then you just type in pip install requests. And then you just run that cell, and then you can just simply import it. Another library that we're going to need is a thing called Beautiful Soup, specifically Beautiful Soup 4. What this does is it takes the content of the request, which is the inner HTML. I'll show what that looks like in a moment. And it's going to parse it to a nice format so that way we can extract things from the HTML. So I'm just going to add it onto here to pip install. You need to do Beautiful Soup 4, like so. And then from there, to import the proper library that we need, you gotta do from BS4 or Beautiful Soup 4, import the Beautiful Soup class, like so. Now, I'm going to demonstrate how to make a request. So we're going to do the response, requests, get, and then our URL, which we'll just copy and paste in a string. So it needs to be a parse string so that way it knows to get the request. If not, it's going to throw an error. And then we can instantiate the soup. It's going to take in, for our case, just these two parameters where it's going to be the content of the response. And then, well, the second argument is going to be parsing it. what kind of parser we want to use. In this case, we're going to use an HTML parser. You can do other things like XML, but for this case, we don't really need it. And then we'll run it. Keep in mind, we don't want to run this cell a ton of times because if you think about it this way, you're essentially hitting that endpoint, that URL every time. And if you run it too much, in this case with Pro Football Reference, they'll ban you for like an hour or so, or a day, depending on the degree of how many times you run the cell. So just run it, and then just do the nice fun work in the other cells. So we do response dot status code. This should return 200, which means it was a successful request. If it's like a bad URL, like if I do, we'll do like an example.com. You get a 404 error, which means it cannot open the URL. Usually that case happens is when like you have if the website is, if it's like a bad URL address, or if you don't really have internet connection. And then the content is this big, ugly written file system of the HTML. And when we parse into soup, looks like nice parsed HTML, which is what we want. All right. I'm going to quickly open up a Chrome tab, and then because Chrome, I can use an inspector tool. I don't have it activated on my Safari. Probably should, because now I gotta reshare my screen. Get rid of this ad. And I'm gonna reshare the desktop. So that way you all can see both screens going on here. All right. So I've got the Pro Football Reference website here on my Chrome tab, and I've got the code in Safari because that's just the default browser that I use. Um, so to get the HTML content, you just right click, hit inspect. Move this out of the way so it's a little easier to read, and bam. So this has all the HTML content that's spewing out onto this website here. We don't really need all this because we only want to get the specific elements for these tables. So HTML, hypertext markup language, that's breaking down the HTML content in things like dividers, headers, table. It just uses things called tags to divide up this HTML to make it output in a nice, clean format. If you want to get a specific element like a table, you can hit this arrow key, the selected element, and let's say I'm going to try to highlight this entire table here. Bam. And it takes us straight to the table. So this is a table with the class sortable, stats table, now sortable with the ID for AFC. For those who don't know, the AFC is just a conference in football, the American Football Conference, and you have the NFC as well. Um, we're going to try to extract both of these. But for now, I just want to give an example of how to extract elements from the AFC table. So we're going to focus on this one. So to get it, let's do soup dot find, and the tag is going to be table tag. We'll assign it to table. And then bam, it just finds the first table, which is the AFC. Then we can start doing some fun stuff with it. So we can play around, see what it has. So we have the col group, which is just dividing out each column for sorting purposes. It's got the table headers. So these are going to be the columns that we want to get. So I'm going to demonstrate how to get those columns. So if we do table dot find all tr, it's going to list all the things in that tr. In fact, I think we do th. Yep, we can do th, and it's just going to get everything inside that th tag. So let's just do one. So dot find is going to find the first instance of this, which is the team. Do dot get text. It's going to return the text. Well, how I'd like this to go about it is just returning a list because it's going to be easier to parse a pandas data frame, which is what you use in Python to manipulate data frames, which is kind of like this table here. So data frames are like tables. So we want to get the columns for those tables. And a way you can parse those columns in, oops, is by specifying a columns parameter, which parameters are like these things like the response.content. And it could input a list. So I'm going to get this here. So to turn this into a list, we're just going to loop through each one because if you recall, this returns a list of each th tag. So we're going to do col for col in this. And if I put it into a list, it's going to essentially do the same thing, like so. Now, if we do dot get text, should just return the text. Bam. Now, I do notice too that it's returning things like the team names, which we don't want. Let's see if there's anything that I'm missing. Oops. Let's just go here. I find all th. Let's just do dot find tr dot find all th. There we go. So this tr is what's dividing this from these other th tags. So if we just do define tr, it's going to go inward to just this column here, or this row with all the columns, and then finds all the th tag or the table headers. So that's what we want. So I'm going to just say cols will equal to that. So now cols is just a list of our columns. Get out of the way, Mike Tomlin. Uh, Next thing we gotta do is get all these stuff with that inside of it. So all the teams, their wins, losses, their winning percentage and whatnot. So how we'll go about this is we gotta do a little bit of background research on this. So I'm gonna use the tooltip again, and let's look at some stats here. So stats are embedded in the table body where they're separated by each tr tag with each row corresponding row number. And then inside you have the th, which is just the team name and their link. And then the TD tags, which have all of the stats that we want. So I'm going to first show how to get the stats, and then I'm going to show you how to get the team names with the corresponding link. All right. So to do this, we're going to have to play around with soup a little, or I guess our table. So we're going to do table, and wonder how specific I can get this. So let's just do dot find tr. Let's do tbody. All right, so we've got the table body. Of course, it's going to return the first instance of the table body. And then we want to do dot find all. And then we'll do the th or td, sorry. Okay. And that should be the list that we want. So you can schedule total. Yep. Yep, this looks right. Okay. Do 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 do. Sorry, I'm just thinking of how we want to do this part. Okay. So in theory, if we do element.get text or element in the table, it's gonna return one large list. Now, this is not really ideal because if we pass this into a data frame, it's gonna be one long column. There's gonna be one column with a bunch of rows. We don't really want that. We wanted this to look more like a table format. So it needs to be a list of lists. So ideally, we want a list with the team name, team logo, and all its corresponding stats. And then bam, next row. Then bam, next row. So how we can do this, get rid of this pajazz here. Trying to think of the best way to hit each row here. Well, if they're split off by each tr tag, we could do tbody dot find all tr, and then we could do like a for row in the tr tag, and then we just print row. How should we do get text? That looks a little better. So each row or each table row or tr has each team and their corresponding stats. So if we loop through using a for loop, each tr or table row, in theory, we should get everything that we want. So let's do it that way. So again, think row as each of these elements inside of it. And we don't really want this AFC East here. So I'm going to just show how to skip that. We're going to do an if statement. If row, and what do we want to check for? So I'm noticing here each tr tag, because they're all tr table row tags, but the ones with the conference names, it has a class called thead one cell. So you want to check if it has it, just skip it. So if row, and it should be the class. There you go. Yeah. If row class is T head one cell. Continue. And then we'll just, once again, print row.get text. Okay, key error class. What this means is say, so this one passes because it's got, actually, no, it should be printing the row.get text. Hmm. I guess another way we could do this is doing this one cell. Since these are TDs, yeah, dot find TD data stat equals one cell. And I need a colon. There we go. Continue. So that works. Yeah, that might be better then. Okay. So what this is doing is it's going to find each TD tag, and we're going to index the data stat, which is extracts this bit here. And we want to check if it's one cell. If it's one cell, we just skip. The other ones are just going to be wins. And voila, we don't have the conference on there anymore, which is good. Next, what we got to do is we got to extract each row bit to a list. So we'll do stats equals, we're just going to continue doing this structure here of doing like a list comprehension. We're going to do row, we'll just do element dot get text or element and row dot find TD, and we print stats 13.8. There we go. Find all, sorry, because that returns a list. If I do just dot find, it's going to return the first instance that it sees. All right, that looks better. A list of lists. So this has all the stats for each row, which is what we want. And we can just save that as like maybe all stats. And we'll just do all stats dot append stats because we want to append each of these to a list. And if I do all stats, bam, it's a list of lists. Maybe not the most beautiful formatting, but it's it's what the desired output is for this because you can put this into a data frame and it'll work. Now, an issue. Coles requires one more column called team. We don't have the team name yet because it's a different tag. So if I hover over the team, instead of it being under a TD tag, it's under a TR or TH tag. So we need a different method of getting this. To do so, we can do team name equals 2, and we're going to do row dot find And we're going to do an A tag. Dot get text. Beautiful. So we've got all the team names here. Last thing I wanted to do is get the link because I think it'd be cool if we can plot the logos as well. And those require the links. So we're going to do row.find A again. And instead of doing a dot get text, it's under a thing called href, which is a reference link. To get that href, we just index it. So I'll just show you again, like so. And now we have all the team links there. Now I do want this formatted properly to where team is at the front. So to append the team at the front, we just insert it. Stats.insert. We're going to insert at the 0th position or the first position. We're going to do team name. And then I'm going to just do stats.insert at the second position, team link. Run that. We do all stats. Bam. We've got the team name, the link, and all of their stats. Now we do need to update our cols because we check the length of our cols and the length of our all stats. It's mismatching. Yeah, sorry. What I did before was printing the length of all stats, which is 16, which is the number of teams in each conference. So you get 16 total of 32 in both conferences. If I index it by 0, that returns how many columns it's expecting, which is 13. So we need to add one more column. Well, what do you think is missing? If you said it was the team link, oh, you're correct. So we'll just do cols dot, and I'll actually do it up here so that we don't deal with any funny business. Cols dot insert at the first position. And we're just going to call this column team link and just run it. So we do cols here. Now we have all this pajazz. If we print out the link, it's now 13. All right. So you know how to get all the stats, but we're missing a whole nother conference here, the NFC. Well, as I hinted before, go back up to the tabletop. There's an ID level called AFC. Well, we're going to want to get the NFC ID as well. So there, you can loop through this if you want. I'm going to show you how to do it with a function. So we're going to define a function called get uh, standings tables. And what's going to take in is going to take a table, which is just going to be our soup object for table. Um, it's going to take in an ID. So we say conference, which is AFC, NFC. We'll just make it optional so that way we don't have to do anything about it. Actually, we don't need the table because right now our table is just finding the first instance of it. So we actually need our soup object. And then in here, we're going to do our table. Keep in mind, this table and this table are actually different. This is what's considered a global variable, which means it's out of scope of things like functions. So if I instantiate a table here, or if I create a variable table in here, it's not going to override this table here. So I can show that in a second if I remember. So it'll be table equals soup dot find, and soup is referring to this soup here for our parameter. And we're going to do, again, table. Instead of just specifying a table like this, we're going to need to specify the ID as well. So we can create a thing called a dictionary, because that's another parameter that the find takes in, where you could specify a specific ID or a class name of what you want to look up. So we'll do the ID as the key. The value is going to be our conf for the conference, and it's gonna throw a fit if I throw in this list into here. So we got to loop through them for, and I'll just make an S. That way it's a little better variable name for conferences, plural, for conf. And conferences, we're gonna do table equals that. And for now, I'll just print table. Don't do that. No, I'll just go in, just throw it into there and show that it works, and then I'll go get back to showing the global variables. Okay. And we're just going to create a variable again, all stats, and just make it outside the for loop. So that way it's not getting a little funky inside. And then we're just going to copy this down here because each table essentially has the same attributes to it, the tr and the th tags, or the td tags. So we just loop through each conference. And then last thing we need to do, or else we're not going to see anything, is we need a return. So outside of these for loops, we're going to do return all stats. So that way it returns us the list that we want. Let's get rid of this. And then just run it. And I'm going to copy paste the function name. So we're going to call it. We want to take in our soup that we defined here. Also, just to not confuse you, I'll do soup equals soup. So that way this is valid as well. We're assigning the soup parameter to our soup object that we made up here. And then we don't need to specify conferences because it's optional since we already defined it here. If we do that, we get all the teams, and I'll specify the length. 32. Beautiful. Now, let's spice this up a little. We've got to, also too, I'm going to delete this cell since we don't need it any longer. Now we need to make this look cool. Oh yeah, the table. Shoot. Before we make this look cool, I'm going to show the table. So this table and this table are different. So if I return this table, it returns just the AFC. So I'll see if I can find an AFC team on here. It's AFC East. In our for loop, the last conference that's going to be outputted in this table is the NFC. So you would see NFC East, for instance, on here if, in theory, this table and this table were the same. So just to show an idea of what local and global variables are. So this is a local variable inside of a function, localized to that function. All right, back to the regular scheduled programming. We need to convert this to a data frame so that way it looks cool. So another library we need to install is a thing called pandas. just pip install it. And we're going to import it. Let's do it here. And I'm going to add on to this function. We'll just do it in our return statement. So we're going to convert this into a pd.dataframe. And it's going to take in our all stats. Then we want to specify our columns. And I'll show pandas data frame, not styling. This is the documentation. If you have any questions about any of these libraries, just look it up. They have their own personal websites with documentation on them, such as pandas. Those are big libraries too, so they should have well-written documentation. And you can do things like look up what parameters does it take in. So in this case, we're instantiating a data frame. So you can do things like the data, which takes in a ND array, an iterable, a dictionary, or a data frame itself. Um, Ours is going to be this ND array here, since it's like a list of lists. And we're going to specify this parameter here too, called columns, which is going to be the columns that we extracted from these table headers. How that looks is columns, we'll specify columns, and then we'll specify that as cols. The first one is data. I don't have data equals here, which, I mean, you can do that if you want, but you don't have to specify in Python because if you don't, it's just going to go into sequential order. So this one's going to be interpreted as the data. The next one, if I didn't specify, it would be index. But if, say, if I wanted to do all stats here, it's going to throw an error. And let me reshare my screen on Safari so that way I can make this bigger. So if I did this, it's going to say positional argument follows a keyword argument. This is the positional argument. This is the keyword argument because we're saying columns equals cols. So Python doesn't know how to interpret this. It can go anywhere. It can be index, could be D type copy. It doesn't know what this is going to do. So putting it here will make it stop complaining. And if I run this, oh, it's going to throw a fit. But I'll show what that means. Soup didn't throw a fit. Ah, probably because we have the globalized variable called cols in here. Just to show for demonstration, I'm going to set cols to something different. Let's say cols equals an empty list. And we rerun this. We get an assertion error. 0 columns passed when it's expecting 13 columns because we made this an empty list. So a way we can get around that is we can specify a parameter called cols just to not confuse ourselves. And then I'll just put in cols there. And then you just have to rerun these two cells like so. So if I wanted to call this something different, actually, say columns, and I rerun this, it would actually work if I specify this as columns. Since columns is going to take in, it's going to become the alias cols, and then it's going to be specified down here. I hope that didn't confuse you. If it did, just leave a comment. I'll try to explain a little better. non-type object. Yeah, ignore that error. That was probably just because I didn't rerun the cells. So when in doubt, just rerun the cell, get everything all reset, and ideally you're following along with this video, not so much trying to code it out at first, so that way you can just see it work in practice. But yeah, this returns the table that we wanted to get with all 32 teams on it. So I can just call this DF for data frame. I'm going to take a couple minutes to show what are some things they can do. So let's take a look at the D types or the data types. They're all objects, aka strings. So if I want to do, say, DF wins times two, it's so the wins, I think the Bills was the first team, so they had 13 wins. If I do times two, it's going to add a 13 onto it, which is not what we want. We want the functionality of these to act as if they're numbers. To do so, we can convert them using a thing called as type, and we can convert it to whatever type we want. Well, I want to convert the wins all the way down to the rating systems that Pro Football Reference has into different data types. To do that, we can do .iloc, which is using the index location. You can use .loc, which will require the column names, but because with iLoc, I just like using iLoc since it's you don't have to literally type out WL percentage points for points allowed. You can just use numbers if you know how to index the row and the column. So if we do colon, which means we're going to index all the rows, and we run this, it's going to output everything again. So row, comma, column, we get everything here. So we want all the rows, but we only want a certain amount of columns. We don't want these first two, so we need to start out at 2 to get the third element and beyond. And then we'll just convert it to an int. I mean, let's do a float. And bam, it converts all this to a float. If we want to save it, we just have to do the df.iloc column for all the rows and then 2 over for all the columns and just set it equal to that. We run it. Now it's all converted. So if I wanted to do wins times 2, it's now properly doing multiplication with floats. Last thing I'll show is you can do things like add columns to it. So if we want to do like a column where we wanted to look at the proportion of points for, we can do that where it's df points for divided by df points for plus df points allowed. So I'm just adding these two here to get the ratio of their points for out of the total points scored in their games. Not really a useful metric at all, but something to show for example. And you can see and what I did here is I indexed the proportion to return a series of that column. If you want to see the entire data frame, make sure it works. You just output the DF and it returns all of the points for. But yeah, that's essentially all I wanted to show with this scraping example, was just how to get a nice clean data frame from that table that we scraped. The next video is going to show how to plot the team logos. We're going to take a look at the wins in response to the point differential. So point differential is just the points for minus points allowed. Um, if you have any questions, just reach out to me either in the Discord or leave a comment below. Yeah, appreciate the time. Thank you and have a good day.